Hello class. Today's lesson will be some fun facts about polynomials. One of the first things you need to understand about a polynomial is they actually have a name. Nope, it's not like George or Mary or Dave or Lucas or something like that. It is a name that's derived from the number of terms in the polynomial and the highest exponent in the polynomial. So the highest exponent is right here, n to the third. It's also referred to as the degree of the polynomial. So the degree is the highest exponent. In this case, it equals 3. So when it equals 3, we call this a cubic polynomial. But we also count the number of terms. And since this particular expression has just two pieces or two terms, we call it a cubic binomial. Binomial, the word bi means two. I think you know that. So a binomial has two terms. And so the name of this particular polynomial, n to the third plus 4, is that it is a cubic binomial. So how about this one? M to the fourth minus 2m to the third plus 5m squared plus 4m. What do we call this one? Well, the highest degree here is 4. Whoops, I'm using the wrong thing. Let's get rid of that. The highest degree here is a 4. Let's use a highlighter. There it is. So 4 is referred to as a quartic. So it's a quartic, Q-U-A-R-T-I-C. That's different from quadratic, quartic, and it has how many pieces? Let's count. 1, 2, 3, 4. So when it has 4 or more pieces, we don't really keep giving them different names. We just say quartic with 4 terms. That's all. We make it easy. We don't keep making up new words. So this is a quartic with 4 terms. So the next question we're going to look at or think about is, what does a polynomial look like? Well, I don't know. I guess I'd have to answer that question. Well, we've studied this one. F of x equals x squared plus 6x plus 3. And we know that that's a quadratic equation. And we should remember that it's a parabola. And because the x squared is positive, we know that this parabola faces up. Okay, it's the parabola. But here's an interesting thing to know. The reason that this parabola has one term is because the highest exponent is a 2, and the number of terms is equal to the highest exponent, 2 minus 1. Take away 1 all the time. So this polynomial will have one term, 2 minus 1. And here's the one term. It only makes one term. So what about this other polynomial over here on the right-hand side? F of x equals x to the fourth minus 4x squared minus 2x plus 4. Well, we know that it's a quartic. We know it's a quartic with 4 terms. But what does it look like? Well, similar to the x squared, if it's x to the fourth and it's positive, it's going to open up. But the number of terms is going to be different, because here we have 4 as the highest exponent minus 1 equals 3 turns. So this will have 3 turns. So let's start here, go down, 1, 2, and 3. There, I've done it. 3 turns, both ends facing up because it's positive. That's not too difficult. So the number of turns is connected to the highest exponent. Now keep in mind that this is the maximum possible turns. Every once in a while it won't have this many, but this is a good starting point. So let's go with it. The next thing we like to talk about is end behavior. And I sort of spoke about that before when I showed you the parabola and said, well, because the x squared face is positive, the parabola opens up. Well, we also know that this too is a quadratic. It's an x squared. And we know because it's negative that this would be an upside down quadratic. In other words, it would open down. It would look like this. But how else can we know where the ends go? How can we know that? Well, we know a few things. We know that the number of turns is connected to the highest exponent. That's easy. So 2 minus 1 equals 1 turn. So once we know that it has only 1 turn, we know that both ends go in the same direction. Okay, so both of these ends, if we were just sketching the end behavior, we would say that both ends fall to the left and fall to the right. So falls to the left and falls to the right. That's one way we can say it. Sometimes they'll show it with 2 arrows, showing you that both ends go down. And another way you can figure it out is to take this -1 and substitute it into the highest exponent, which is -x squared. And if you put it in there, you'll find that -1 in place of the x, whoops, sorry about that. You substitute the -1 in place of the x, so now you have negative and -1 squared, which is still -1, and that tells you that the end on the left-hand side, on this side where the -1 is, must be going down. And since it's an even number, I know that both ends go in the same direction. So I can just kind of sketch it as I want to. There, that's my parabola. How about x to the third? Well, we know that when it has a power of 3, the number of turns is going to be, is going to be 3 minus 1, which is 2. But how do we know where we start? Do we start with the end down and go up, or do we start up high and go down? Well, you can use my little trick with the -1 if you wish. And if you take the highest exponent, -x to the third, and I'm going to switch to pink because I'm going to substitute in that -1. So I'm going to put in -1 to the third. And if you bring a negative number up to an odd power, it stays negative, and then multiply by the negative sign in the front, and suddenly you have a +1. So that tells me that this end on this side, where the negative numbers are, goes up. Okay, and because it's an odd number and it has to have 2 turns, well, the only way I can do that is if it goes down and makes 1 turn, turns around, comes up, and makes 1 more turn. So you see, the ends have to go in opposite directions. Okay, now this isn't a precise graph of this polynomial, but it's a close replication of it. I mean, I could plug numbers in and make a precise plot, but we tend to not do that with polynomials because look at how big they get. Look at the size of this one. Who wants to make a data table for this? I don't. So again, let's do our little trick. First of all, we know that the highest exponent tells us the number of turns. So the number of turns for this one, let's make that view better. The number of turns for this one will be 3 minus 1. So 2 turns again. Okay, so it's going to have 2 turns in the graph. Then we can take our -1 and plug it into the x to the third. So I'm going to do that. And I'm going to use my pink again. So now I have -1 to the third. Well, a -1 raised 3 times, multiplied 3 times, stays negative. So that means that on the negative side, when the x's are negative, this particular polynomial must be heading down. So it's heading down on the left side when I put a negative number in. So then all we have to do is start there and make it have 2 turns. So up we go. There's 1 turn, come down, there's the 2nd turn, and up we go. And do I have these turns in the exact right places? No, I do not. I would put this into decimals if I wanted a precise graph. But if I want to just pick out the right graph based on the number of turns and which way the ends go, this would work pretty well for me. So here's a little cheat sheet just to review. A positive x squared has 1 turn and both ends go up. A negative x squared has 1 turn and both ends go down. A positive x to the third falls to the left and rises to the right and has 2 turns. Negative x to the third rises to the left, falls to the right, and has 2 turns. Positive x to the 4th looks like a W. Starts with both ends going up and has 3 turns. Negative x to the 4th sort of looks like the letter M. It has 3 turns and both ends go down. Positive x to the 5th, take a look, is similar to x to the 3rd except it has more turns. So it falls to the left, rises to the right, and has 1, 2, 3, 4 turns. Obviously, if the positive x to the 5th falls to the left, the negative x to the 5th will rise to the left. It still will have 4 turns, and then it will fall to the right. And that's my little summary. I hope you enjoyed it.